is the world's leading supplier of structural eccentric mass vibrators, and I'm going to explain what an eccentric mass vibrator is. This is our smallest model, the MK110, but it is illustrative of all the models that we have. It consists of two counter-rotating weights. As you can see here, there's two weights inside, and because of a gearbox on this side of the vibrator, they rotate in opposite directions. Right now, they are set so that they point out either horizontally to my right or horizontally to my left. Therefore, it's creating uniaxial horizontal force. And the two shafts are connected through a belt system with a pulley right here, and the purpose of that is to change speed ratios for the motor. But by slipping the belt or slipping the weights inside, it is possible to have the vibrator shake completely horizontally or completely vertically or at any angle in between. The way these vibrators are used is to attach them to some kind of structure of interest, anything from an electrical cabinet to a turbine pedestal to a full-size nuclear power plant containment. And then this induces a sinusoidal force into the structure, and it responds. Depending on the frequency, it will have resonances, and therefore you can use this machine to determine the resonances of any structure, also the structural damping and the mode shapes. By using this information, you can check to see if finite element models of that structure are accurate or if they need to be modified. Note that in larger vibrators, the weights are not placed internally. They can be removed to reduce the weight of the vibrator for transportation purposes. But again, in this model here, there are 4 split weights, which allows you to change their angle and adjust the so-called eccentricity of the vibrator. By doing that, you can adjust the force at any given frequency. The vibrator is typically run by a variable speed electric motor drive. So as shown right here, we attach a flex shaft to this point right here, goes over to the motor, it rotates, and it can control the speed of the vibrator to great accuracy, less than a couple of tenths of a % of frequency. So we have vibrators like this one that can test electrical cabinets and piping systems. We have vibrators that can shake entire dams or nuclear power plants or other important structures for the purpose of structural investigation.